Hi, good morning. Today we are going to discuss about some distributed system related design patterns. In technical point of view, distributed systems are playing vital role nowadays because the thing is, in olden days we used to have client server model, or we used to have MVC model. So most of the time, see, the applications would be designed in such a way that we will have a client and we have a server. We'll deploy the applications in server, and then the users will access the server. So, but the things are changed now. We can see the technology evolution, how the technology stacks are invented, and the business also changed. So nowadays everything is globalized. So most of the businesses, multinational companies, they are operating at global level. They are going to have clients or customers at global level. So let's say if you are going to create any website for your business, and it can be accessed by multiple people from the multiple different countries. So that is the business now. A global it's a global level business. So you need to have infrastructure in such a way that it could support the global user traffic. So how do you design the architecture for such kind of requirement? You see, you take any banking application. So most of the corporate banks, HDFC, ICICI, or you take any other, they operate at an international level. The customers also, some people may use the HDFC or ICICI from North America, or West America, East America, or Russia. Some people may access from Russia, some people from Europe, some people from Britain, from some people from India. Same way for ICICI Bank. They are global customers, who generally use these the banking application. I'm just talking about banking application. You can take any other domain also. You can take supply chain management, e-commerce. Amazon, Flipkart, eBay. You look at them and you look at their businesses, how they are operating it. It's a global scale of business operations, right? Their operations are global level. They actually, process millions of transactions every day. So for that we need a proper infrastructure, you need to build, you need to design the system in such a way. So how can you design that? So that's where we will talk about the distributed system architecture. It is one of the best architecture, because if you want to handle the load, the global load, you need to scale up your resources, your servers, your application instances. You need to scale them depending on the dynamic load, because you don't know when you will get a huge number of clients for a particular day. You don't know that when the business is in high mode, or when the business will go into the low mode. You don't know that, right? It will happen dynamically. So when the requirement is like that, you need to have a flexible infrastructure with you. So let's say in olden days, the people they generally buy 3 or 4 servers, the fixed servers, and they'll configure all the things. They'll install all the softwares, and they'll establish the network connections, and after that they'll deploy the applications into the servers, and they'll configure the load balancing and all. It is a fixed, you know, the 4 servers only will handle the maximum capability, maximum capacity, maximum load traffic from the users that are coming from the different regions, continents. And let's say if the load is getting increased, if the user traffic is going to be high, and if 4 servers are not able to handle it, imagine what will happen. The systems will go into the hang state, right? And they will be overloaded. They may not operate very well as expected to handle such a load of the business users, right? So that is why we actually need to have a distributed system architecture design. You take any business examples, they are mostly preferring distributed architecture only, distributed design, because using a distributed design you can scale the systems, you can scale the applications, you can also scale the servers horizontally, you can also scale the servers vertically. You can make it as a dynamic infrastructure, system infrastructure for your the business when you are going to use a distributed system design. So there are so many design patterns out there to build a standard distributed system design. To build a successful and standard distributed system, you need to follow some design patterns, standard design patterns. So today I would like to discuss a couple of those design patterns which will be used generally. These are very important. And when you talk about distributed system, in distributed system you have multiple servers connected together in a cluster. Alright, so let me talk about the first design pattern is the ambassador design pattern. You can see in this diagram there should be some wait a second. So ambassador design pattern, you can see generally it is a kind of proxy to handle logging, monitoring, handling retries. There is an application code. You need to have a proper structure for logging and monitoring, for building resilient service. If any service is going to fail you, there should be some retry mechanism. So generally using ambassador design patterns, you can actually build a kind of proxy to handle all this logging, monitoring, these things, retries as well. So when you are building applications, so logging and monitoring is very important. The thing is, you need to have a proper logging because you want to see what is happening and how the how requests are propagating among multiple services or multiple servers, how your requests are going to be processed, how the load is going to be handled. You can look at your CPU cores and memory usage, CPU usage. You can actually see the metrics, of course health metrics, server metrics, and performance related metrics. You can actually watch all those things using this logging and monitoring mechanism. Ambassador You can actually build a proper ambassador, follow the design pattern to build a proper kind of proxy to handle all these uh, services properly. Okay. Second thing is circuit breaker mechanism. You see here, circuit breaker design pattern is a very important. So when you want to build a resilient microservices, it is very important to have a circuit breaker design pattern, follow the design pattern, because sometimes when you are building multiple microservices, some of these services may be stopped or may not work due to some load issues or other issues. You see, that time you need to have a mechanism. Let's say if a service is failed and other service is trying to call service B is failed and service A is calling, and service A will get an exception if service B is not responding. And there should be a mechanism, internally you need to configure, like whenever certain service is failed, the calling service should wait for some time, and after some time it has to retry, it has to call the service again to get the results, expected result. So you need to build in such a way, you need to automate that, you need to configure it, right? So that's why we use a circuit break mechanism. In generally, whenever the calling service is trying to call some other service and the service is not responding, and your actual service should render some basic details, some necessary details to the client, right? So that the client will not get vexed with the response data. Meanwhile, the calling service keep on calling the other service which is not responding for certain period, and as soon as it gets to online, then it gets the data and it render back to the client. So that is a kind of circuit breaker mechanism here. I'm just trying to explain conceptual information here. I'm not getting into the technical part, so try to understand the scenario here. You can actually configure a certain failure threshold. Let's say your calling service may try maximum up to 3 times and it does not respond, right? Then you need to kind of open you kind of what is that, you kind of open circuit. Okay, if it is responding, if the other service is working, then you may close that circuit, then actual thing work properly. Okay, so this is how you can say there are 3 stages: open, half open, and closed. If it is not working, maximum threshold reached, just open the circuit and open timeout. So you need to attempt a reset. You can open half open, okay, and try to check the status, and if it's working, then completely close the status. So that way you can use a circuit breaker mechanism to try to understand the concept here, scenario. So the thing is, you need to build a resilient microservices. That is what I'm trying to tell here. How resilient your service. Let's say if you simply build thousands of microservices and you established a communication. Let's say some of these services are not working suddenly, and your calling services, what they will do, they will show the exception, or they will show some improper data to the client. Imagine if the customer logged into the ICICI bank and he is watching the transactional details. Suddenly some exception details occurred on the banking. What happens? The user, they will lose the trust on your bank, right? They will lose the confidence on your bank. Whenever the customers lose any trust and confidence, that is a huge loss for banking systems and domain. I'm just giving an example to you. So you should make sure such kind of issues will not occur. Even if they occur, right, at least you should show some meaningful, trustable information, attractive information to the user, saying that, let's say, we are processing your information, please wait for some time. If you say that, at least it will not solve any issue exception there, and the customer can wait, he may wait, or you may show some technical issue occurred, so please revisit, like that. You need to show the proper message. So that's where the resilient system design pattern will come to the picture. I'm getting my point, right? Resilient systems means you need to take care of all these scenarios. So whenever your service is not working, how do you respond? What kind of response you would use? You need to create a fallback methods. What is your fallback method? What is the message, expected message and fallback method? And how do you configure the retry mechanism? How do you design this? So you need to handle the circuit breaker mechanism, resilient 4J. You can also call this. So in the technical point of view, how do you handle the fallback mechanism is important thing. And other thing is a ladder election design pattern. You see, when you have a distributed system, you have multiple servers connected together in a cluster. You may have 10 servers, 20, 30, or you may have 100 servers, thousands of servers, depending on the business, right? So the business that is operating at a global level, you may have 1,000 servers, you may have 500 servers, right? You need to configure the cluster to handle such a load. So couple of servers may reside in North America, couple of servers may reside in India, couple of servers may reside in South America, or couple of servers in London, couple of servers in Russian region, because you need to have that. So the thing is, whenever the user wants to access any data, your request may go to the nearest servers as per the load balancing mechanism and content delivery network. You need to serve the content delivery network, right? Catch the content network data using content delivery networks. So clustering these servers in different regions and connecting them with one another is very important thing. Okay, that is fine, but how do you manage this multiple server? There should be a leader, right? There should be a coordinator. There should be a leader who actually selects, propagates, decides, and orchestrate, these things. There should be a leader. So because whenever the request comes, goes to the leader, and from there, the computation, the processing will be distributed, or the master will decide to route this particular request to certain server in a cluster for a particular region. So these things has to be handled. There should be a leader, and there should be corresponding working nodes, right? You need to design a system. Okay, you take some examples. So distributed systems, electing the leader and configuring the worker nodes is very important thing, so that there will be a leader, master node, who actually orchestrate and manage the computation well, and decision making, and most of the routing mechanism you can actually configure it master also. And if master is down, and immediately another working node among the multiple distributed system will be elected as a master node. So that is why this leader election design pattern is also important thing. You need to consider that. I'm going to talk about CQRS, command query request specification. See, so here the thing is, whenever you are actually writing data in distributed systems, you need to separate both writing and reading, because you are actually working with multiple cluster of nodes, not a single cluster here. Getting my point, right? So the thing is, if you are clubbing both writing and reading as a single service, it may lead to ambiguity, sometimes data inconsistency issues also. So that is why what you need to do here, you need to separate both. You see, both write logic is a command. We can call it as a command as per the design pattern, and reading part as a query, as a query part. So there is a UI, and users are trying to register, users are trying to submit some data. Then the command service will get executed. It will actually write the data to write database. Okay, and the write database, what it will do, it will be configured in such a way it will actually propagate all the data to read database. It will send that data. We can actually use some asynchronous mechanism here, event driven approach, to read the events and get the data into read database. So we can actually sync both the databases, but the actual writings will happen with the write database in live. The live transaction will get updated with the write database using a command service, and from the write database the data will be synced to the read database. So if customer is trying to read the data, he will read the data from read database, not from the write database. Write database specifically used for writing the data. So here we are segregating it, command, query. We are separating the command and query as per this design pattern. You can see this here, okay? And we want to separate it in order to build a proper and performance effective system, distributed system. We need to separate it out. So that is why most of the microservice based architecture, they're still preferring to use CQRS design pattern in the design. Okay, and another thing is event sourcing. Event sourcing design pattern is very important, especially in banking applications. So take a banking applications. I work for the American Express client project. So whenever we are dealing with the customers who are having American Express client, right, they actually do the multiple transactions, right, every day. You take a global level audience and they are all using American Express card. If everybody using that card for multiple transactions every day, you see how much data it is going to be generated. So you need to store all the data. Let's say if the customer today morning he used American Express card and he actually withdrawn $100 from his account, and the balance is showing now for example $700 are pending there. Okay, 700 or 600 you see, and now after some time the user actually again he purchased something, so I actually swipe the card, American Express credit card, then the amount, or debit card, what happens, the amount will be decreased. So in the morning it showed him the $800 balance, and in the afternoon it showed him only $200 are there. So because you used card for multiple purchases, right? So for every transaction details we are going to save in the database using a timestamp, right? You see, each thing is an event here. Everything is an event, and you should not ignore the historical data, because the latest data is $200 but the morning time is having a $700 $800, right? So he spent because there are multiple transactions. So you need to keep the historical data also when we are talking about the banking applications. Each and every event, every event. Let's say you may update some data also. You may deposit. Um, you may deposit some amount, or you may withdraw some amount. For each transaction, the updates will happen, and you need to store each updated information. You should not ignore any information. What I'm telling is, whatever the event happened, right, for each and every event you need to store a record in DB. Of course, the historical data may not have the impact on live transaction except the latest data, because latest data only used by the person, right, for any transaction. Historical data is just for auditing purpose. So that is the reason. That is why tomorrow you want to take a snapshot, or you want to roll back to certain transaction, and you want to see that. Okay, you can do that. If you are able to store these all the event related data using event sourcing design pattern. So what I'm telling is, event sourcing design pattern is the pattern which actually stores the data of all event occurrences, right? So the data could be useful for auditing purpose. You can also roll back to the certain transaction amount or certain period of data. You can see that historical purpose. You can track all the information. That is why event sourcing design pattern is one of the key design patterns. Most of the banking applications, they still follow it, because they always record each and every snapshot. Let's say in the banking, the people at certain period of time, the people updated a record, customer data with some details, and later point of time again they updated with other data. So when they updated with other data, they will not lose the previous data. They will also store the previous data somewhere in the table. They will not lose it, because they need to have a track of all the updates that happen to particular customer from the beginning to the end. So you need to take care of that, because you are dealing with the transactions, you are dealing with the money. Once the customer loses the interest and confidence, right, you will lose the business. And this makes the huge difference in business, right? So that is why you have to take care of all these details. Event sourcing design pattern is very important thing. You need to take care of this design pattern when you are building the proper distributed application. Other thing is, you take the sharding is one of the best design patterns. In general, when you are dealing with the global audience, your business is operating at global scale, and it will generate millions of records every day. It may generate huge volumes of data, and all the data, if you are going to store in a single database, it will be very problem. And no single database can handle such a huge volumes of data, and it is not a good idea to store all the data in single DB and applying all the database writes and reads on the same database. It is not recommended approach. So when we are talking about distributed, you need to shard the data into smaller databases. You need to store them into smaller databases. You need to shard into smaller data sets, and you need to store them into different smaller databases. And you have to handle the ultimate consistency, eventual consistency, like making sure all the data is in sync. And when you are trying to get some data, you need to have proper aggregations, and you need to render the expected data. You need to handle all these things at application level, possibly at database layer also, using stored procedure or something. You see this having a huge volumes of data in different data nodes is preferred approach, because they'll be faster, multiple databases, storing data in multiple databases, and so that you can easily handle the volumes of data. You can take the snapshots, you can handle the data. If it is huge volumes of data, even your applications or your database objects or applications, they may not work properly because of the performance issue. If the data is very huge, when you hit a query for a particular database which is having terabytes, petabytes of data, it may take a lot of time to render a response. Let's say if you have a data sharded in different databases, and the accessing time will be very less. You will have a very less latency time, and data will be fetched and the data will be aggregated in the application, so you can show the data, final data, to the application. So that's where sharding is one of the best design patterns. Still using it. And other thing is public and subscriber event bus. Nowadays we can never imagine any system design without event design driven architecture. Publisher and subscriber, so most of the design systems, most of the systems, they're actually using this event driven architecture, event driven design pattern. Let's say they want to generate alerts, they want to send notifications, and they want to let's say based on some events they want to take some action. They want to propagate data from one data source to another data source. There are so many use cases. So event driven architecture, publisher subscriber, we can also call it as publisher subscriber. So publisher is nothing but a program. What it will do, it will publish some events, some data into into some queues, or you can call it as a event bus also, you see. So after that, all the subscribers, whatever the subscriber, they subscribe this particular event bus, particular queues, they can actually get the data. It's a kind of post office kind of architecture. You see, we are posting something and other side they'll receive it. We're posting it to the specified address, and then the receiver or whoever are processing the specified address, they'll receive the data, they'll receive the letter, right? The same way we are doing it here. Publisher means we are going to publish some data. Okay, we may publish some events, we may publish some API data, we may publish some the data based on the clickstream or user actions, or you may publish some file processing information in the back end if you are dealing with the backend systems. So there are many use cases. The thing is, publisher is generally used to publish or post some data into a queue, and any subscriber is a program which actually reads the data which was published by a particular publisher. So the subscribers can subscribe the same queue, they can subscribe different queues. We can actually configure that. So one message can be read by multiple subscribers also. So it will copy is going to be distributed to multiple subscribers depending on the business requirement. So this is how we actually handle the data. And thank you for listening.